So today we're starting with graph interpretations, and we're gonna go straight to polynomial functions. And I've got a polynomial function here, and let's call this case one or scenario one. In this case or scenario, I've been given three x-intercepts. So I've got the three x-intercepts. So the only thing I need to determine is these unknowns, like the b, the c, and the d. Okay, so I need to find those unknown values, and we know that d is the y-intercept. So the constant right at the end of your function, that's always the of a polynomial, it's always your y-intercept. But in this instance, I don't know what my y-intercept is, but I do know my x values, and I do have my x values. So let's just remove this to keep my graph quite neat. Okay, so I've got these three. So now, what would be the logic? Now, let's go back to when we did parabolas in grade 11. So when I did a parabola in grade 11, and I've been, and let's say, for instance, I've been given two x-intercepts, I would have used this formula where this x over here is this value over there, and this a value would have been this, and then you will just FOIL out all your values, find a point, sub it in, and you would have gotten your function. Okay, so let's use this same formula, because what stops me of using the same formula? Nothing. I've got my x-intercepts. So in fact, I could actually go x minus x1, x minus x2, and I've got three x-intercepts, so x minus x3. Okay, so this value over here, this -1, I'm going to punch it into that position over here and sub it in there. I'm going to sub this into this, and I'm going to sub this into this. Okay, so let's do it. So I've got a equals, y equals, do I have a's value? I do have a's value as 2. So that makes it much easier. So x minus my x1 minus 1 makes it a +1. X minus x2 is a +1, and x minus 2 is my third intercept. And then I'm just going to FOIL all these out. So let's just FOIL all these. So x squared. I'm not going to take a shortcut, just to show you that you can actually take the longer way around this as well. So it's +1x minus 1x. You're more than welcome to do the shortcut, x minus 2. So let's just keep this 2 on the outside of my bracket. Let's simplify this. So you could have gone straight from there to this position. It's fine. Okay, I'm going to keep my 2 outside, so I'm just going to multiply all these in. So this is x to the power of 3 minus 2x squared minus x plus 2. And now I'm going to multiply my 2 in with all these factors. So this is 2x to the power of 3 minus 4x squared minus 2x plus 4. So did I answer the question? Yes, I did, because they said in the beginning, find the value of B, C, and D. B is actually easy, so let me just see my color code. So B was in blue, C was in green. Okay, so my B value is -4. Okay, that was in blue, sorry. -4, that was my B. Green, that was my C value. And 4 was my D value. So I actually found the unknown values. And then a secondary question on top of this could be, find the stationary points of this graph. So for a start, I need to find this stationary point there, and I need to find the stationary point over there. And what do we do? So for stationary points, we usually take the derivative. Oh, sorry, that's the wrong pen. We usually got the derivative now, but you have to be careful now. this has not been given as a f function. So I have to rewrite in a slightly different way. So we need to get the derivative. And the derivative, because we're using y and x's, we're going to say it's dy over dx. And that would be equal to 0. So this is very important. So if this was a fx function, I would have said the derivative is equal to 0. You always get a mark for that. But now I can't use f of x because this function has not been given a name as f of x. So let me just remove this. So this is going to be very important to write. I need to say that my d over y, my dy and the dx is equal to 0. So the derivative of this function is equal to 0. Why is it 0? If I ask now, remember that for stationary points, turning points, the derivative is the gradient, and on those points the gradient is 0. So that's the reason why we make it 0. So we're just going to sub this to 0. So we're going to find the derivative. And remember how to find the derivative. You take your exponent, multiply with your coefficient. So this becomes 6x squared minus 1 from your exponents. The 2 times the exponent times the coefficient minus 8x. Subtract one of the exponents. And then this x got a 1 exponent. So this becomes just negative 2. Okay, so now we need to factorize this. Now the easy way of doing this would be rather, let's divide everything with a 2. So this becomes 3x squared minus 4x. So we're just going to divide all my terms with a 2. Okay, and I don't think this can factor. So we're probably going to use our formula, which would be x equals minus b plus minus. So if you use your formula, you need to go and write it down. B squared minus 4ac all over 2a. Remember that I've got my negative b, which would be then a positive 4, because this is my b value, plus or minus b squared would be then negative 4 squared. And you have to show the substitution. That you don't have to write this, but you have to show your substitutions. So that's very important. A is then 3. My c value is negative 1. All over 2a, and a in this instance would be 3. Okay, I'm going to punch everything in my calculator. From there onwards, it's going to give me 2 x values. X equals 2 plus root 7 over 3, which means we've got, in theory, 2 x-intercepts, 2 plus root 7 over 3, and we've got x equals, or x equals 2 minus root 7 over 3. So now I've got 2 x-intercepts. Now which one is which? So this is obviously my smaller x value, and this is my bigger one. So the smaller one will be that turning point there. So we've got that x value which just worked out, and the bigger one, or the larger value, would be this x-intercept over here. And if I want to find the y-intercept, I'll just sub this straight into this formula, which we did find. We did find it over here, so we'll sub it into these to find my y values of both. Okay, we're going to look at scenario 2. Now you might look at this scenario, this case, and think, now I've only got 2 x-intercepts. In theory, you still got 3 x-intercepts. But one of them are just one common point. So in theory, I can still use these. This formula, where this x-intercept over here would be my 1x value, and then this one would be both, because it touches my x-intercept. So it's the same point in theory. And then what's nice about this equation, I can actually find my a, because I've got these 2 points which I can sub in. Okay, so let's do this. So we've got y equals Let's just do it step by step. X minus and the minus 3, that becomes a positive 3, and then x minus, so this becomes a negative 2, and another negative 2 because it touches the x axis. So we can try to simplify this, but the easier way is to sub one of those points in now before you try to simplify. So let's sub this 3 and minus 6 in. Remember that every x value would become a 3 and every y value would become a negative 6. So negative 6 equals a, 3 plus 3, 3 minus 2, and 3 minus 2. So this becomes quite easy. A, and this is 6, and that is just 1 and 1 and 1. Okay. So my a value would be 6a equals negative 6. So a would be negative 1. Now we need to find the function. Yes, so let's just rewrite everything. So unfortunately there's no shortcut on this. Let's just write the whole formula down. This is what we've used. Now remember that I know what a's value is, negative 1. I know what the one x-intercept is, so it's 3. I know what the other x-intercepted is, my minus 2, and then the other one is minus 2 as well. Now unfortunately we just have to go and FOIL out all these three brackets. So x times x is x squared. Minus 2x plus 3x would be a positive x, minus 6, that would be my first bracket. And then I have to do it again. Negative 1. Keep your negative 1 for last. So we're just going to get one huge bracket, and then we multiply the negative 1 into that bracket. So this is x to the power of 3 minus 2x squared. And so it's this times this times that. The x times x is a positive x squared, minus 2x, and then minus 6x, and then there's a plus 12. So let's just simplify this. X to the power of 3, these are similar terms, so it's minus x squared. These are similar terms, so it's minus 8x plus 12. And then from here onwards I can distribute my negative 1 into this. So it's negative x to the power of 3 plus x squared plus 8x minus 12. So now did I answer the question? I did, because they said find find the function, and we did. So this is the function. So this is my a value of negative 1, my b value of positive 1, my c value of a positive 8, and my d value as a negative 9 or negative 12. Okay, so let's have a look at case number 3. So this is my third problem. And what do I have? I've got one x-intercept, but I don't know where it is, so I probably need to find that at some point. What do I have? I've got a turning point here, or stationary point, and I do know it goes through 0 and 0. So let's have a look at all my unknowns, so that I can work it out. So I've got a b, I've got a c, and I've got a d. And I need to find those unknowns. So d would be y-intercept. And what is my y-intercept? It's more 0. So at least we can start off with this by subbing my 0 into d. So that makes total sense. Now I need to find b and c. So what do we do when we've got unknowns and we need to find those unknowns? We sub a point in. Is there a point that I can sub in? Yeah, there's an obvious one. So let's just sub this obvious point into my equation. So x is going to become a 2, y is going to become a negative 32. So this becomes negative 32 equals minus x is going to be 2, that's to the power of 3, plus b x to the power of 2 plus C, and X is 2, and D is just a 0. I'm just going to leave it out because we don't write any plus zeros or minus zeros. So let's just simplify this. So this becomes negative 8. This becomes 4b. This becomes 2c. And I still got a negative 32 on this side. So let's just simplify it further. Then we can take the negative 8 across. Then that becomes a positive 8. So this becomes negative 24, I think. Yeah, negative 24. And I've got 4b plus 2c. We can still simplify further by dividing with a 2 straight through the bank. So let's just divide every term with a 2 and just become C. So let's make C the theme. So we can take then plus 2b across, so it becomes negative 2b, and we'll call this equation 1. Okay, at least I've got two unknowns. I've got some sort of equation, so I need to find another equation. This is obviously, this is the more difficult part. Okay, so what do we know? We do know that this is the turning point, this 2 and minus 32. And we do know if we take the function and we derive it, and we make derivative equal to 0, we find the turning points. Okay, so let's do this. So let's derive this function. Now remember, it's not f of x, so I can't derive it this way. So let's just rewrite it in a different way. So I'm going to say the d of x over the d of y is equal to 0, because we're going to make it equal to 0 because the gradient is 0, x equal to 0. Okay. So let's derive this. D of x over d of y would be 3 times a negative 1, a negative, it's negative 3x, and subtract 1, 2, plus 2bx, subtract 1. So this 2 multiplies with this, and this one is going to multiply with the c, so it's just c and subtract 1. Yeah, so it just becomes c. We make it equal to 0 because the gradient is 0. But I need to find these unknowns, the b and the c. And do I have an x? I do have an x. So, but x is equal to 2. Therefore, 0 equals negative 3. My 2 squared plus my 2b, x is 2 plus c. So this becomes 4. So this becomes negative 12 plus 4b plus c. Let's just make c the topic of this. We'll take this across, so it becomes 12 minus 4b. And we'll make this equation 2. Now I've got two equations, both equal to c. So we can sub one into the other. So let's just sub 2 into 1. So we're going to sub the 2 into the 1. So this is my 1. And this is my 2. And I'm going to sub that 2 into my 1. So just make them in colors for you. Okay, so let me just rewrite 1. 1 is minus 12 minus 2b equals c. But I know what the value of c is. It's 12 minus 4b. So I can actually find my b value now. So I'm going to take this 4b across, becomes a positive 4b. So this 4b minus 2b is just 2b. Okay. This negative 12 goes across to that side, becomes a positive 12. There is a 12 on that side already, so it becomes 24. So b becomes 12. And let's call this equation 3. Now I need to find c. So I'm just going to sub 3 into either 2 or 1. So just make it easy for myself. So I'm going to sub 3 into this so I can work out my c. So c equals 12 minus 4, and b is 12. So c equals 12 minus 48. So c equals minus 36. So I've got an equation of y equals A has been given, so that's been given. B is my 12 plus 12x squared minus 36x, and then plus the D, which is obviously 0, but we're not going to write the 0. Okay, so let's have a look at case number 4. So case number 4 gives me, so there's a graph, and there's two stationary points. Let me mark them for you. As at A and B, there's two stationary points. So what do we know about stationary points? The gradient is exactly 0. So we know that if we derive this function, so we get the derivative, we know what the gradient is, so this becomes negative 6x. We're going to minus 1 of the exponent plus 2bx plus c, so that's the derivative of the function. So in fact that's the gradient, but what do we know? That the gradient on those points, on the turning points, are 0. So we know we can actually say that the gradient is 0 at those turning points, but we know what the x values are. See, because I've got an x value here of 2, so we know that the derivative is equal to 0 where x is 2, and we can do another equation where x is 5, and that's also equal to 0. So we've got both these turning points, so we can implement, we can substitute x into that equation, into the derivative, and make it equal to 0. So we can say 0 equals negative 6x, but x we do know the value, 2 squared plus 2b, and x is 2 plus c. Okay, so this becomes negative 24 plus 4b equals c, all equal to 0. Let's just move it upwards a bit. Let's get C as my subject. So we'll move the 24 across, becomes positive, minus 4b, so that would be equation 1. And we're going to do it where x is 5 as well. So we know that the gradient is 0. Where x is 5, we're just going to sub 5 back into the derivative. Okay, so that will give us, is this negative 150, I think, negative 150 plus 10b plus c. Let's make c the subject, so we'll take the 150 across, minus 10b, and that we'll call equation 2. Now that we've got two equations and we've got two unknowns, we can do simultaneous equations. So we're going to sub 2 into 1. Okay, and I think this is obvious. You've done this since grade 10. So we'll both know that they're both equal to c. So we can, in theory, say 24 minus 4b equals 150 minus 10b, and we can find the b value. So we're going to take the negative 10b to the left hand side, it becomes a positive minus 4b, and we'll take the 24 across to the other side, becomes a negative 24. So we know that 6b equals, that should be 126, is it? So let's just see, we add 2 there, yeah, so it's 240, yeah, so that seems right. So now we can find the b value. We can just divide by 6 on both ends. So this cancels out. So b equals 6 goes into 12 twice, and 6 goes into 1. So we know that the b value is 21. And now we can find the c value because we've got b. So we're going to sub 3 in any of those equations. Let's just take the easier one. Let's just take equation 1. So we're going to sub that into those, into equation 1. So 24 minus 4b equals c, but we know what b is, so let's just sub that back. But we know what b's value is. B is 21, that's equal to c. So 24 minus, is that 84? I think it is, equals c. So c should be 24 minus 84 should be negative 60. Negative 60. And now we need to find the value of d. So let's just recap where we are at the moment. We do have the value of b and c. And what do we've got the value of A, we've got the value of B, we've got the value of C. So in fact, we've got, let me just rewrite it on the side. So let's just recap. We've got f of x equals minus 2x cubed plus b is 21, plus 21x squared, plus c, do we have it? So it's negative 60 x plus d, we still don't have. Okay, now we've got an unknown. Now we can just plug in any point. You can choose a point. So let's just sub any of these points in. Let's choose the easier one. I think let's go for, I think 2 and negative 9. I think 2 and negative 9 is the easier point. So let's just sub 2 and negative 9 into this equation, where x is 2, y is negative 9. So this is negative 9 equals minus 2. X is 2 cubed plus 21, x is 2 squared minus 60, x is 2, and then let's find the d. So I'm just going to plug this into my calculator, and I'll get a negative 52 plus d. So d is an amazing, would it be 43? Yeah, 43. And I can just sub my 43 back into this equation, which is 43. And those are the 4 possible cases.